Good afternoon. It's good to be back in Australia. Air Marshal Davies and the team, I'd like to thank you very much for inviting me to this and giving me the opportunity to speak. I think maybe the staff pushed past disruptive when they invited a Marine infantryman who studies history to talk about technology for the Air Force. We may have gone right past disruption and irrationality. We'll see if I can do better than that. Now, one of the things, Americans don't know much about Australia, so I thought it'd be a good idea to show you one of the views we have. I don't think this is what your tourism industry wants, but that's the view. I'm a little concerned that by the end of this talk, the pilots in the audience will think this is a pretty good idea. Now, disclaimer, I am still working for the US government, but nothing I say is, it's all my opinion. DOD does not necessarily agree with me, and nor does National Defense University. So the topic I was given was uninhabited aerial systems, disruption or prescription. I would say a little differently. They're both autonomous, will be unmanned, they will be autonomous, and they are inevitable. And my fundamental thesis is that within 2 decades, they will dominate the air domain. And we have to think about how we're going to make that transition. And they're going to dominate because of superior range to manned aircraft, vastly superior numbers, lower cost, and the fact they will not need fixed bases like our current family of manned aircraft do. So what are the things that are going to make this happen? This is in the short term, again, the next 10 to 15 years. All of these things are here. Now, some of them exist now, and I'll talk you through them in turn, and why this will change the dynamics between manned and unmanned aircraft. The first is the fact of small warheads. Now, you see that little plastic cylinder about the size of the explosive tech's hand. That is an explosively formed projectile. It has 30 grams of explosives. For the American room, that's 0.07 pounds. And it has a tiny little copper penetrator in a plastic tube. So for about 70 grams, I can devise a weapon that will punch through a half-inch of steel. Obviously enough to destroy an aircraft on the ground, to destroy most wheeled vehicles by going at the engine compartment, getting a mobility kill. Now, what's going to make this really interesting is nanoenergetics, which is the US Navy's polite way of saying explosives. Already in the unclassified realm, they show us having 10 times the power of TNT for the same weight and mass. So as you begin to experiment with this, you begin to look at the thought of, well, maybe a Tomahawk land attack missile with a 1,000-pound warhead really comes out equivalent more to a 8 to 10,000-pound warhead if you change the explosive load. And what does that mean for delivery systems and potential? The next thing is 3D printing, and this gives you capability plus volume. If you look at this picture here, the gentleman there is a researcher at the University of Virginia, and the Marine Corps asked him if he would build a small drone force, 3D printed drone, that could hunt autonomously. It took him about a year, but what they developed is this drone you see here. He 3D printed the body and it snaps together. The little electric motor he bought online. There are 2 batteries he bought online, and one of the grad students had to give up his cell phone. Now this has a 50-kilometer range, autonomous. They only flew it out 25 and 25 back because the kid wanted his cell phone back. Total cost, $800. This is an autonomous system which can hunt out to 50 kilometers. To put it in comparison, the Javelin anti-tank system, which hunts out to 2 kilometers, costs $195,000 for the round. That does not include the launcher. Now, in the bottom picture is 3D printers. Since this was printed in 2014, when it took them a little over 26 hours to 27 hours to print it and a couple hours to assemble it, printer speeds have increased between 100 and 200 times with carbon 3D printing. That is a fact today. He's pushing it, and he thinks he can get it to 1,000 times faster. So the one printer that printed one of those in a day can now print 100 to 200. So if you look at what UPS, and they're getting into the printing business because they think printing is going to gut shipping pretty badly, UPS is putting up a plant today, has it built today, that has 100 printers in it. If you had carbon 3D printers, that's 10,000 autonomous drones a day out of a single plant. Of course, if you reach the 1,000 printers they plan to put in that plant, that's 100,000 drones a day. That's the kind of numbers you may have to deal with. Is it possible to mass launch that many? Well, obviously, if you've got that many, it's nice, but if you can't get them out, it's really irrelevant. But what we've seen in the corner there, the tubes there at the top, is the US Navy's Locust system. And that launches a larger drone like the one you saw. And these are totally coordinating drones. So they're somewhat larger, somewhat more complex. But what it illustrates is that that container, which kind of looks like a 20-foot container, can fire about 30 drones. In the lower corner, you'll see the Chinese Harpy system. That's an 18-round launcher. The Harpy is a fully autonomous system. It kicks out, can fly 600 miles, deliver 50 pounds of warhead, and it hunts in both IR, visual, and electromagnetic spectrums. It was initially designed as an anti-missile system to take out anti-air systems. It goes after radars, but they've changed it into hunting on other systems. So you can mass launch them. Now, the next thing that's going to happen is AI, and this is not complex AI. This is AI that does task-specific things, like fly to a certain grid, look for this collection of targets. This is a priority. If you find one, suicide into it. Now, the DX3 is a Canadian system that's designed for exploring the high north for exploitation of materials and minerals. It has a range of 900 miles. Costs about $200,000. That sounds expensive. It's about the same as operating an F-35 for 3 hours. The one in the lower corner is the Flex Rotor. It has an operating time of 45 hours, multispectral imagery, a range of 2,000 miles. Lower left corner is the Tern. This is a Navy experimental. It's a much bigger platform. It's a 30-foot wingspan on that, vertical takeoff and landing off any platform at sea, delivers 500 pounds, 900 miles. In the upper corner is the Kratos QX222. Kratos has been making drones for the United States for a lot of years, and they finally said, why don't we apply this? They've flown a successful version, UTAP-22, as part of a swarm with the Harrier controlling 3 of these downrange. This is planned to be an autonomous system that will deliver 500 pounds, 2 small diameter bombs, a distance of 1,500 miles. It has stealth configuration, but not stealth coatings. So it comes in pretty cheap. They say if you will buy 100, they'll sell them to you for $2 million a copy. Let's say it's a normal DoD project and the price goes up 50%, then that's still only $3 million a copy. That is cheap enough to send on a one-way trip of 3,000 miles, at which point it kicks out whatever missiles or bombs it's carrying, and then they hunt. But again, this is task-specific AI. I'm not asking you to do hard things, I'm asking you to do specific things. Now, what the heck? How can you use a weapon that goes out 3,000 miles? Well, you got to see what you're doing. And this is cheap space. In the upper corner there is Rocket Lab CEO. This is the guy that has created the new space power of New Zealand. They launched this bird, they got it up, and it actually worked. They had a little bit of problems, but they plan to do it quarterly launches and then down to monthly launches. And what they launched is the CubeSat you see there in the lower picture. It's 4 inches on a side, and you think that's not very impressive. But over the years, they've figured out a way to marry several of these together, and they can give you imagery down to 2-meter resolution. A slightly larger version called a KegSat, because it's about the size of a dorm room keg, and that's where it was designed, will give you resolution down to 1/3 of a meter. Lower corner there is, of course, the Indian launch that put 104 satellites up in one launch. 88 of those satellites belong to a company called Planet in the United States. Their business model is to sell an image of anywhere on a planet taken every 24 hours with interpretation. Bottom line is, they will know where your bases are. They will know where your ships are. Within 4 years, this company plans to do that every 6 hours, and it has a business model that's attracting the money to do it. So now you've got this problem of cheap drones plus cheap cruise missiles, because 3D printing advanced manufacturing will also reduce the price of cruise missiles, and you can start to think differently, which the Russians are doing. This is their family of weapons they sell in 20-foot containers. For a specific reason, it's hard to preempt 20-foot containers because there's so many of them. Look out in any aerial imagery of any city or base area, and you'll see dozens of these things out there. They have the entire Caliber series of missiles. Now, admittedly, it didn't have a great record flying out of the Caspian Sea into Syria. They had a failure rate of 10 or 15%, but if you're launching enough of them, it doesn't really matter. And if you have complete surprise launch, your time from detection to launch is less than 10 minutes. You won't know this is a missile system until the lid starts to come up. Their land attack version can go 1,500 miles, so your air bases simply aren't safe. It can be either hauled around by a truck, or like in the lower left corner, it can be done by one of these ships. Or, if you think very differently, China has 200,000 ocean-going fishing vessels. Almost any of them can handle a 20-foot container. Many of them have 20-foot containers. So this is a threat. This is the convergence of technology that brings together massive numbers of cheap autonomous weapons. Now, one of the things we're counting on to protect ourselves against this, of course, are directed energy weapons, laser and microwave specifically. Now, the good news is that laser and microwave both provide an advantage to land-based systems, defensive systems, because they can plug into a power grid that allows them to have a great deal more power generation, a lot more shots. If you have to take your laser airborne or out to sea, you've got a power limitation. We're working to overcome that, and we may be able to get there. The other huge advantage of a land-based laser, of course, is concealment. It's very hard to see systems in the background clutter of a city. And if they're a mobile system, like many of MAR, the US Army is developing mobile systems, you can literally put them in a parking garage. You can put them in a bus garage. You can hide them underground until minutes before you need them, and then you roll them out, establish them, and shoot. Of course, the key weaknesses of lasers are smoke, haze, and there's been some unclassified writing on possible reflective coating. I don't know, you'd have to go deep into classified, I think, to find out about that. But smoke and haze, we do know has an effect, certain weather effects. And I'm working to overcome those, but it's really tough to base the idea that you will survive on a fair weather system. That should concern you. Microwave weapons, back in the Cold War, we put Faraday cages, which is simply a metal cage around your electronics to route the power pulse around it. It was to defeat the EMP pulse that comes out when a nuclear blast is set off. Well, as long as you're 3D printing the electronics on a drone, and we are doing that today, why not print a Faraday cage around it? It doesn't absolutely protect it from electromagnetic weapons, but it does increase the number you need and the ranges they have to operate at. And of course, if you use ground avoidance, and we have ground avoidance already in cheap drones, then you can pick a route in that minimizes line of sight time of defense. If you look at something like the air base at Bagram and you study it through Google Maps, you will see that the closest Afghan village where Afghans live today is 1,000 meters from where we park the C-17s and the rotating 747s and other civilian birds that rotate our troops. Would seem to be a fairly easy problem with a modern drone to get out there. And even if all you bring is a bag of gas and drop it on the wing and ignite it, I guarantee the Air Force is going to think twice about putting more C-17s there. It's simply too valuable an asset to risk that way. So where does that mean we are? Well, there's a historical pattern to this. And the problem is that a system will get replaced over a period of time. It doesn't happen instantly. And normally the problem is as new technology is developed or new concept is developed and somebody figures out a way to integrate this with the old system in an operational concept that makes it an assistant. As that technology improves, you improve the operational concept, the training, the education, and you begin to use it as a partner, and then finally it's a replacement. Now, a perfect example of that is the carrier aircraft. As you look at aircraft first coming into use, the Navy looks at them and says, you know, not very good, but hey, they can look over the horizon. They can be an assistant. The battleship needs to see over the horizon. So they start to do that. As the aircraft gets better and more powerful, they move to an aircraft carrier. One of the reasons, of course, if you catapult it off a battleship, you got to stop and pick up the pilots. They're kind of whiny about that. And so you've got to go back and get them. That's bad for a battleship. So you have them land on a carrier. Well, then as the carrier aircraft improve and you develop fighters, dive bombers, and torpedo bombers, you find it becomes a full partner. In 1936, the US Navy ran an experiment of a surprise carrier raid on Pearl Harbor and sunk our battleships in the game. The umpires disallowed it. Then the Japanese ran a similar simulation a few years later and were not disallowed. So by 1942, the carrier has replaced the battleship. And so there's this transition from assistant to partner to replacement. And this goes back through a number of things. You think about the pikeman versus the armored knight. If the armored knight could get close enough, he could easily kill the pikeman. The thing to remember is the new system rarely has better capability than the old system. The advantage it has is range. So this requires aggressive, honest experimentation. And by honest, you've really got to keep people from resetting the clock. Like I said, the US decided we'll just disallow sinking the battleships, and that'll solve it. The Japanese did the same thing before Pearl Harbor, when their experiment showed that the US surprised their carriers and sunk 3 of 4. So they reset the game, reran it, and then of course it won the way it was supposed to, which is their battleships cut our carriers and sunk them. Then we ran the real battle, and we sunk 4 of their carriers. So we've got to avoid that. Inertia and unions are your other big problem. Unions in the US, and I think a great example of that is we've built this X-47 drone that has flown off carriers. It has enormous capability and range. But in the fight over what it should do, the pilots union in the United States have relegated it to purely refueling, because nobody wants to do that job. So rather than looking at how it can take over the deep attack mission, which we don't have an aircraft that can do, or others, they relegated it. And this is part of inertia in that militaries are inherently conservative for good reason, because you have enormous risk when you introduce something new, but there's a huge amount of inertia that comes with that. So where are we in the air domain in this assistant partner replacement? Well, if you look all the way at the bottom at assistant, in electromagnetic warfare, we're starting to put up some drones that have EW systems on them. Same thing with ASW. We're starting to fly drones off of, or have been flying drones a long time, the old Dash helicopter, which didn't work very well, but we've improved it. And then communications relay. In partner, in deep strike, very much the Tomahawk missile is a full partner. A lot of times it's used to open a path for the fighter aircraft to go downtown. Naval anti-surface, the same thing. Missiles are beginning to replace aircraft. And anti-air warfare, we're beginning, like I said, the UTAP experiment with the Harrier in the range. They found that actually works, because the UTAP doesn't have to have a lot of brains. It just has to get the missile to the right place to release it so it can pick up and go after the target. And then close air support. And we're already a full replacement in persistent surveillance in a low-threat environment. Drones have completely taken over from manned aircraft. There's some still use of P3s, but if you've got a drone, it's just frankly cheaper. And then high-risk strike. Ever since the first Gulf War, we have been sending cruise missiles downrange to places where we don't want to take the risk of losing a pilot, because you get in an awful situation like we had in Lebanon, where we had to negotiate for the return of our pilots. So the immediate issue is range obsolescence. And this pattern, if you look at the armored knight versus either the pike formation when the Swiss pikemen beat the French armored knights, or the crossbows and longbows, which the French took 3 times to figure out that was what was happening to them. Pike formation versus musket formation. Again, it was not that the pikes were less effective, it was that the muskets could kill them before they could get close enough to use the pike. Same with battleship versus carriers. And the key things to remember is it's still superior. The battleship today could deliver more firepower in less time than a carrier. It is also much, much physically tougher than a carrier, much harder to sink a battleship than a carrier. But it's totally irrelevant, because it can't get close enough to the carrier to make a difference. And there's a market cost advantage. When we first started sending aircraft after battleships, the F-6F, the frontline fighter of the US Navy in 1945, cost $35,000. So you could buy lots and lots of them. This was the small, smart, and many of the era. And they could throw against the battleships with the market advantage. So what does that mean for us today? Well, this is the problem. This is a range chart in nautical miles of the various drone, ballistic missile, and cruise missile systems that are flying today against the F-35. The fundamental problem is, even with conformal tanks like on the F-16 and F-18, you don't get a massive increase in range. But we do know that drones are increasing rapidly. Like I said, a few years ago, we were getting 100 miles out of a drone. Today, they're getting 2,000 miles out of a drone, and relatively cheap drones. So this is going to be a problem. The other thing is, one of the objections to AI is the possibility to jam. And this is why you've got to go fully autonomous, non-GPS dependent. Non-GPS dependent goes back to the old TLAM in the 1990s. Initially it was inertial nav plus visual. There was no external signal. You launched it, it went silent and went in and hunted its target. That is now much cheaper, because think about how much computer power cost in 1990 as opposed to today, and imagery capability as opposed to today. The other big reason this is happening fast is Amazon wants it. Amazon has a requirement out for a drone that'll lift 20 pounds, 100 miles, GPS independent, and hardened against radiation, because they want to be able to fly it in their airfields. They don't want to get hit by a radar and shut down and lose their package. It also must be cheap enough that if they lose the thing, they don't care that much. That is going to make it commercially available. A lot of this stuff comes from commercial systems, and that's where the great advances will be, both in range and capability and ability to hunt. So the fundamental problem is, how do I get the F-35 close enough to the fight that I'm not destroyed on the ground? Because frankly, if I'm an enemy planner, I have no intention of fighting the F-35 in the air. From everything I've read and the pilots I've talked to, it's going to be a great system. We've got bugs to work out. We'll throw enough money at it, we will work those bugs out. So why bother to hunt it in the air when I can hunt it on the ground? The Center for New American Security did a study they call First Strike, and if you look it up, you've got to get the two-author version, both Schubert and Gonzalez, because they released it that was caused such a problem that they pulled it back and released it with only one author's name and dumbed it down. But the first version looked at a surprise Chinese strike using missiles, cruise missiles, and drones against US forces in Japan, using 20% of their SRBM, short-range ballistic missile force, 30% of their medium-range ballistic missile force, and between 30 and 80% of their cruise missiles, because we don't really know what the count on those is. They could hit every US headquarters, every US ship in port, crater every runway and taxiway long enough to take off from, and kill 200 US aircraft on the ground. That's the opening 30 minutes of our war. And the fundamental problem we have, there's nowhere to back those aircraft up to that are within range of China. And these are not hugely expensive systems. Again, the Harpy, or Harop, 600 miles, can get to Okinawa from the China coast. The other big problem is these are all vertical launch systems, so you don't have the advantage of knocking out their airfields. The idea that you're going to roll them back as part of a campaign is a little iffy because they're on trucks, and we have not demonstrated the ability to actively hunt mobile systems, particularly in a cluttered environment. When they break cover, the time from breaking cover to launch is about 10 minutes. That would require an enormous number of orbits over China all the time to put a warhead on a forehead in 10 minutes. The other thing is trade-offs. Remember operating costs. The F-35 costs $140 million to buy and $65 per operating hour. A loitering TLAM, and I use this is a very old system, but it's usable just because it gives you an idea. We paid $1.1 million a number of years ago. With additive manufacturing, we think it can reduce the cost 40% to $600K. The $1.1 million was a very limited run. We never buy as many TLAMs as we should. And of course, the QX22 is offered for $2 million. So your trade-off is you can have one F-35 or 230 TLAMs or 70 QX222s. And using only operating costs. Now, when I say operating costs, that's just the way the US government charges it. That doesn't include aircrew training, it doesn't include the maintenance crew training, it doesn't include the people who operate the airfield, it doesn't include air traffic control, it doesn't include golf courses or O-clubs. So by not operating the F-35, I can buy 15 more TLAMs, and that's an F-35 squadron of only 10 and flying a minimum number of 15 hours per aircraft per month, or 5 more QX222s. So in essence, every month you don't have the fighters that you have these, your combat power can increase for the same amount of money. So where are we in the conventional air domain? Well, frankly, what I would do, again, if I were the enemy, I would attack your 4th and 5th generation aircraft on the ground and your key enables. And the Chinese have made it very clear that they're working hard to take out AWACS and tankers in the air. And we do this when we have a red team together. I was talking to some guys the other night. The red teams work very hard at getting the tanker and the AWACS because they know that's a huge advantage. But suppose I can do it with cruise missiles. Launching out of Guam doesn't do you any good if I can hit Guam, and they now can hit Guam. So you're launching where? Out of Hawaii or Alaska? How many tankers does it take to get you there? How long can you sustain yourself there? I can also strike logistics and C2 nodes. While cyber is not something you normally think about using drones against, remember, every element of cyber resides in the real world somewhere. It's on a server, it's passed through a node, it comes through a cable, there's a downlink antenna. All of these are susceptible to strike by cheap drones. So I can also use it as a cyber weapon. Evolved cruise missiles and drones are going to take over most manned aircraft missions, again, within 2 decades. There will still be some that we will need for special purpose missions, but we've got to start thinking in those terms. Because the fundamental question is the manned fighter range obsolete? And a question I always ask US airmen who are wanting to spend billions of dollars on the B-21, the new long-range bomber, do we really think anybody's going to let us fly those bombers out of Missouri and not go after Missouri? If you take one of those, or a box of those cruise missiles and put it on a merchant ship and put it in the Gulf of Mexico, you can range all our bomber bases. And Google Earth will let you know where they are if you don't want to buy it from anybody else. So my conclusion is autonomy is inevitable. The key thing, and this is the good news slide, there is some good news in this brief, even for pilots. The good news is you can lead the transition. Let's face it, all of this is happening fastest in the air domain because of the physics. Air is simpler. Things are more subject to rational rules in the air domain than they are on ground or underwater. So you can lead this transition because you're the first people being forced to, and have 2 goals. First is seize the advantage in each stage, and we're already doing that. It's kind of in our DNA. When you look at the way we've married cruise missiles with strike fighters, and we're using types of drones that are allowing us to get the strike fighters in, things like that, we're seizing the advantage in the early stage of making them assistants and partners. Now we've got to start working through the mental process of how do we make them the replacements. And we've got to rethink operational concepts. We've got to experiment ruthlessly in free play, some lives, some virtual, mixed together. And then you've also got to have tabletop games where you just explore the logic of it and really be ruthless. Make sure bases are not off limits. Very often the way you can justify the continued existence of the fighter is the base is off limits. Or if you've ever played a US Navy war game, every game I've ever been in, we sink the carrier and it never seems to make it to the brief. Because if you're so short-legged like the F-35 coming off the carrier, then your problem is how do I justify a $13 billion carrier? And then become an aerospace force. I mean, if New Zealand can become an air power, you guys have already got it in your plan, but I think there's a real possibility, and this is a natural place for the Air Force to lead. Lastly would be study how other have succeeded. Millett and Murray's wonderful book on innovation in the interwar period examines 6 nations and the progress they made between World War I and World War II, and why some of the innovations succeeded and some of it failed. And there's some interesting characteristics there, and you can examine your organizations. And finally, perhaps the key thing aviators have to do is maintain air-mindedness. I'm very concerned that if ground and naval forces get the idea that, hey, we can strike far enough with these missiles that we don't need air forces, that you lose that idea of thinking of air as a fighting domain, and we've got to maintain that. So that's the good news. We're going to need you guys air-minded. Okay, and I'll be at the speaker's corner. And for the fighter pilots, I guess the phrase is fights on. Thank you very much.